Thanks. Okay, I'm back. I'm here to talk about a tool that I've built called RCC, which checks BGP configuration on routers within a single AS, tries to find errors. I came 2 nanogs ago and described sort of described the tool in kind of box diagram form, and today I'm going to give a demo and also some reports of some things we've found, and hopefully you'll find it interesting. Great. So I could almost skip this slide because we've had a lot of complaints about BGP this morning already. Ratul came here a few years ago and talked about BGP misconfigurations, and lots of other researchers have noticed many and varied problems. And one thing to take away from this sort of laundry list of complaints is that BGP's behavior is largely determined by how it's configured. So if we want it to be doing the right thing, we need some way of checking, are the routers configured correctly when we turn things on? Is the behavior going to be the way we want it to be? Now, I noticed I was put in a session. It was just myself, a grad student in computer science, and Ratul, who's also a grad student. So even though we're researchers, you're probably thinking, this stuff doesn't really happen in the real world, right? News reports and various things would suggest that these things do happen, and depending on who you ask, these types of outages, if you ask an ISP, they blame the vendor. If you ask a vendor, they blame the ISP, right? So what's really going on? Well, what I did is I looked at the NANOG email archive just to sort of figure out what types of problems people actually are reporting as far as, hello. Okay, thanks. What types of problems people actually are reporting in terms of things that look like configuration errors, et cetera. And what I did, so I was able to spend about a day reading the NANOG email archives and actually convince myself that I was doing useful work. I don't know. Anyway. So what I did was I clustered these emails according to thread, and then what I did is I sort of looked at what these emails were talking about. Were they things where people were complaining about a particular type of problem? And the numbers that I've listed that are not in parentheses are things where people have actually complained. So filtering was, if someone is filtering such and such a prefix, or someone should be filtering such and such a prefix, and they aren't. Things like, someone seems to be leaking this route. What's going on? Someone's stealing my route. Global route visibility. Things like, hey, I'm announcing this prefix, but I can't see it at all my at all the places that I should be able to see it. Like, whoever's filtering this, please stop. That type of thing. And then there are various other things that I noticed people complaining about. Things like, people sending trace routes, with routing loops, or things that just die in a black hole. And this isn't really a scientific study, but I just want to sort of illustrate a couple of things. One is that there's certain things that seem to be fairly chronic. These filtering problems, for one, seem to come up a lot. Another thing that I kind of noticed was, there are emails that I was looking at like this year. They're talking about filtering problems, and you could change the date to like 1994, and it was pretty much the same email. Like, these problems are the same things that people have been addressing for a long time. All right, let's try to make some progress here. Okay, so besides just looking at email, we can also just sort of look at some empirical evidence and see what types of routes are getting leaked in various places. So what I did was I've got these iBGP monitors that are sitting in 8 different ASes that are spread out in various locations on the internet. And what I did is I looked at the BGP updates that we're hearing at these monitors over the course of 11 months, basically from today back until last July. And what I'm showing on this graph, let's first look at the red line. It's basically just a time series plot of how many bogon route advertisements do we see at any one of these vantage points in a particular week. And by bogon here, I'm using the Team Kimru definition of bogon. So this is both private address space and unallocated, but about half to 2/3 of these announcements are actually in the private space. So this would indicate that people aren't even really doing the easy things as far as filtering bogons. I've listed a URL here. I'm actually actively collecting these types of things, and I'm looking for more vantage points if you want to give me one hint. So even though I probably didn't need to convince you of this, hopefully I have convinced you that we've got some problems on our hands, and it seems like there's sort of two logical ways that you could go forward, or two possible suggestions, right? One is that, well, obviously we've got a buggy protocol. It doesn't do things like allow negotiation. We can get wedgies. Let's just toss it out and replace it, or let's add some things and hope that these problems go away. Well, what types of things do we need to fix? And if we start out with some new protocol, it's going to have to support a lot of the same things that our current version of BGP has to support. So how can we ensure that this new protocol is going to be any less error prone? Are these problems with filtering, with black holes, et cetera, are they going to go away? We need to answer these questions if we're going to try to propose a new protocol. The second thing we can complain about is the configuration languages. Say, oh, these, Cisco or Juniper or whatever configuration language is too low level. We should, redesign it so that it's, reflects what we want to accomplish at a higher level. And again, it's sort of hard to figure out, if we want to fix the configuration language, what parts of the language are people actually messing up? What types of things would we want to make go away? And in order to do that, we really need to study, like, what types of things that people are getting wrong in their configuration today before we can propose any types of reasonable fixes. So here's my proposal to you. What I'm giving you is a tool that uses static analysis. By that I just mean it's grokking the static configs and pulling configurations off routers and then doing offline analysis of the actual text of the configurations and trying to find configuration errors. Okay, so I'm hoping that a tool like this can actually help networks be less error prone, allowing operators to find certain types of configuration problems, common bugs, etc., before actually deploying the configuration on the routers themselves. The other thing, this, not entirely altruistic, right? I'm hoping that, with your help, people like me can figure out, what types of problems are actually happening in real networks. So if we were to propose, protocol changes, changes to the configuration language, what types of things make sense so that we can make these problems go away? So here's a URL. I'm going to show it to you a few times, but this is your first chance to go check out some information on the tool. So let me just sort of describe to you at a very high level how the tool works. So first thing that happens is the router configurations are sucked down off the routers. And then there's a pre-processing module. Basically, all this does is expands things like peer groups and things like that, just to make the configuration a little easier to parse. I'm not going to show you that in the demo that I'm about to show you. So once that pre-processing happens, basically going to take sort of a cleaned version of the Cisco or the Juniper or what have you, and parse it into an intermediate configuration, intermediate format. And what that's going to be is basically MySQL database tables. So it's going to be a nice, like, abstract representation of, here are my sessions, here are my route maps, here's what my network looks like, if you will. And then what I can do is, run a verifier on that and say, here, now I've got this nice abstract representation of what my network looks like. I can start asking questions like, do I have this right? And I'll spend the second half of the talk talking about what I mean by that. Okay, so it's showtime, but first, since we're in the land of Arnold, I thought I'd use a Hollywood-esque type disclaimer to say that, yeah, this is entirely fictional. I've used my imagination here, and I don't mean to be, referring to any ASes, alive or dead. Okay, so basically, so I'm going to show you the second two boxes. The first thing I'm going to do is relatively unexciting, but I just want to show you that it's very easy. You can do it on your own network, and you should. Basically, I just run something that parses through. I basically got 3 routers here. I just ran that script. It parses through the Cisco configs of those 3 routers. It will spit out things immediately, things that it can't parse, like if I've got a BGP session that defines a route map, but I don't have the route map defined, then it'll complain about that immediately. But we'll see more of that later. But basically what I have now is at the completion of running this script, I've got a nice like intermediate representation of my config. So let me just kind of show you what that looks like. I'm not going to show you the entire schema, but I just want to give you kind of like a flavor of what this looks like once we've got it in an intermediate format. So basically, I'm just showing you one table here, which is the sessions table, and that shows, of course, like the router name, which means, you know, this is the config I grabbed this statement, or this is the router I grabbed this config statement from. Here's the neighbor that it's going to. Is it a route reflector client session? You'll notice that column here is fairly uninteresting, but I'll tell you why that's important later. You know, which AS it's going to, and then the one thing I wanted to highlight here is that, you know, I've got import route maps and export route maps, and you notice that it's a little bit nonsensical, right? You'd kind of expect to see something like private or peer or anything, but basically what I've done is I've canonicalized route maps, right? So often you'll, you know, have, you know, for example, to like AS4321 here, you might have private or, you know, exchange point in or exchange point out as a route map on two different routers, but you may actually, you know, that may mean two different things depending on, you know, whether you're on router A or router B. What I've done here is say that, okay, if I've got a route map that's called route map 2, that is actually the same route map. So what you can do is then sort of look at what the canonicalized form of these things are. So let's see what I'm doing on, you know, the import route map to this particular session, right? And I can say, oh, okay, it looks like this. You know, if I match a particular AS path regular expression, then I'm going to assign it a local preference, and I'm going to permit it and deny everything else. And if I look at the route map for the other session, then I can sort of see what that looks like. And notice I don't have to do things like eyeball the config to sort of manually dereference AS path access lists, or notice that even though they're both called exchange point in or something like this, that they're actually two different things. We've pretty much all taken care of that. So then once I've got this intermediate format, what I can do is run, I can run my verifier on it, right? And this is sort of what I'm going to spend the rest of the talk talking about, and what I'd like to have sort of more help and suggestions on. But basically you can run, and these are the flavor of errors that we want to, that the tool spits out, right? So, you know, the parse errors that I showed you before, you know, where I couldn't actually parse into the intermediate format, but other types of things where, oh, you know, it doesn't look like you've got a full mesh IBGP. Let's say, you know, I've got two peers like 4321 and 1234. Like, I want to make sure that I'm not transiting between the two peers. These types of errors report that. And then there are other types of things that, you know, minor annoyances, things like, oh, I notice you've got a BGP network statement, but there's no static route to it, and there's no redistribute. Like, did you really mean to do that, or maybe should actually clean that up? And then other things that you know, maybe of general interest, like, oh, you know, deterministic meta's off, synchronization's off, synchronization's on, sorry. Believe it or not, we found that mistake. You know, are you using non-deterministic tie breaking? May not be an error, you may have meant to do that, but these types of things maybe you'd want to know, right? Okay, so now that I've given you sort of an overview of kind of what the tool looks like. Oh, and I should mention, like, of course, that output, you know, looked a little messy and wild, but one of the things I've added to the tool is actually sort of a web interface where, you know, you can run that script that I just ran for you, and then it'll spit all these things out into a slightly more friendly format. If you want to make it friendlier, then feel free to help me. I'm not a UI expert. Okay, so for the second half of the talk, really what I want to talk about is how this verifier works, how I've designed it. You know, give you sort of an overview of the types of things we are testing now. Talk to you about sort of some things we've found by looking at configurations in 9 ASes, and then talk about why I think these problems are happening. And then at the end, I will again shamelessly plead for your cooperation. Okay, so the first thing I want to do is talk about, you know, this design of the tool, and obviously I've talked a lot about verification and what it means for the routing protocol to be correct, but well, the first thing we need, of course, is a definition of correctness, and you know, for something like shortest paths routing, the definition is pretty clear, but for something like BGP, it's a little less clear, right? So the first thing I've done is defined correctness in terms of 5 properties. These aren't meant to be exhaustive, and if I've forgotten something, I definitely appreciate you telling me. But let me just sort of summarize each one of these properties. The first is pretty obvious, right? It's called validity, and that just says, is my routing protocol going to advertise routes that are bogus? Like, if someone tries to use this route, will their packets not get to the destination? As we've seen, these things can actually happen, and we want to check for those things. The opposite problem is something called visibility, and that just says, if there is some path between a router and some destination that could be used, that packets would actually go this way and that it's conformant with policy, etc., then will my routing protocol actually tell me about it? And I'll show you an interesting example of where that's violated in the next couple of slides. The third sort of recognizes this point that many people brought up this morning, which is that often operators don't really want to expose certain types of information to other ASes. And one thing I mentioned was, am I transiting between two of my peers? I want to make sure that those types of routes aren't leaked. There are two other properties that I've included in my definition of correctness that I'm not going to talk about a whole lot in this talk. Partially because there's certain things that I think static analysis isn't really that useful for, particularly this property, like will we have oscillations based on policy, things that people have talked a little bit about this morning already, and those may be better suited for protocol changes. Okay, so this slide should be fairly obvious to you, but I just want to sort of raise it because obviously we have this definition of what it means to be correct, but how are we going to actually apply it? Well, in order to do that, we kind of need to figure out, like, what are the things that BGP is really doing, and it really boils down to about 6 things, right? So, there's origination. A router may export that route to another router. When that router hears it, it's going to import it, do some stuff, decide whether or not to accept it or not. There's the path selection process. The router could modify attributes, and it could also propagate that route to other routers inside its own AS, the IBGP. So putting these things together, the properties of correctness and the steps of BGP operation, we can sort of start to get a little bit of flavor for something that looks a little less ad hoc, right? Which is at each step of operation, what types of what aspects of correctness could possibly go wrong? And I'm going to talk a little bit about some of these in the next couple of slides. But you can imagine, validity can obviously be violated on origination, right? You can originate bogus prefixes, for example. The idea here is to try to find a systematic way of asking, at what stage can particular aspects of the routing protocol go wrong, and knowing these things, how can I write static analysis checks to make sure that they don't go wrong? And if I can't, then what types of changes should we be making to the protocol or languages so that I can? So let me just sort of walk through that table a little bit, give you a few examples, and in the process, I'm just going to use examples that our tool RCC actually checks for, just to give you an idea of all the types of things we're looking for. So bogon prefixes I've already gone over, but there are other things related to AS path that we also check for. So on export, like, are you prepending the same AS that that you belong to? If you're using customers who are speaking BGP, but you're using private ASs, are you removing that private AS before you re-advertise it to the world? You'd be surprised. I gave you that bogon URL earlier in the talk, and you'd be surprised how many private ASs leak out, or maybe you wouldn't. I don't know if you've been looking. Maybe you wouldn't be surprised, but there are quite a few. And then various things that we also check, other types of things for filters. Are there sessions defined that don't have route maps at all? If you define a route map and you use access lists or AS path lists or community lists, like, are the things you're trying to use, have you actually defined them? How are you setting the next hop attribute on sessions to other on your eBGP sessions? Like, if you're not setting next hop self, well, you better be sure that the interface that's on the other side of that session is somehow injected into your IGP. That should say IGP, not IGR. Otherwise, you've got reachability problems. So let's talk a little bit more about the second property. This is visibility. There are obvious things like synchronization, network statements without routes. One thing that the tool isn't currently checking for, but that I plan to add soon is, are you filtering prefixes that have recently been allocated by Aaron or Apnic or Ripe or whatnot? You'd be surprised again how many people don't update their filters when prefixes are allocated. And something I want to spend a couple slides on is this IBGP signaling issue, which is related to this property. If I have a path, is my routing protocol going to tell me about it? There are obvious things to check for. Again, duplicate loopbacks, cluster IDs, etc. But there are other ways that IBGP can be partitioned that you may or may not be familiar with. Obviously, we all know about full mesh. But things get a little more interesting when we start adding route reflection, right? So in case people don't know how this works, I imagine most of you do, but let's just sort of quick review. The default is, the router is not going to learn an IBGP learn, it's not going to re-advertise an IBGP learned route via IBGP. So you're going to need n squared scaling. People recognize that this was a problem, and in the usual fashion, we've added another feature called route reflection. And the way this behaves is, route reflector clients just behave as normal. But route reflectors then will re-advertise their non-client routes to all their other clients, and they'll re-advertise the client routes to both non-clients and other clients. Okay, so this seems pretty simple, right? Great. Well, it turns out that maybe it is simple in a lot of cases, but there are situations where things can happen where you might not expect, and you might end up with routes not propagating as you'd hope. So let's sort of take this simple example. We've got a router W that's a route reflector. It's got two clients, one of which I've labeled X. X has a regular IBGP session to Y, and Y is a route reflector of its client Z. Okay, so I don't know if you see what's coming here, but if X speaks EBGP to some neighboring AS, and it learns a route, then everything's hunky dory. Everyone learns that EBGP route. Great. Well, what happens when what happens if W is speaking EBGP? Well, W's clients, of course, hear that route. But X, remember, X is just behaving as usual because it's a route reflector client. It learns that route via IBGP, and it's not going to re-advertise that route to Y. So now we've got a problem. We've got an EBGP learn route that should have been re-advertised to all the routers inside the AS, but that's not happening. And this is just a simple demonstration of how something that's fairly simple, like a route reflector hierarchy, can go horribly wrong. And that's kind of one of the things that we want to check in the tool. And this is an example of where static analysis can help. You can imagine that this type of thing would be rather, depending on the advertisements you hear from your neighbors, it could be rather difficult to figure out what's going on if you don't have a way of diagnosing it. So I'm going to jump back into research land here and give you sort of a non-scary theorem for how to check this type of thing. And this is the type of thing that RCC actually does. So the first thing we do is just check for a fully connected graph and something that doesn't actually contain cycles between its route reflector client relationships. Then basically what we can check is that the situation that I just showed you won't actually happen if every router that is not a route reflector client of any other router forms a full mesh among those routers. So basically if you've got a full click of all the routers that are not clients of anyone, then you're fine. It's pretty. The intuitions for that's pretty obvious, but I'm going to skip over that. So I'm just going to talk about sort of one last correctness property. I'm going to skip the last two and just talk about this information flow control thing. Am I exposing information that I might not want to expose to other ASs? Now, obviously, this is sort of a complicated requirement, and actually figuring out how to spec this is fairly difficult. But we can sort of make some reasonable assumptions about what types of things people usually do, or what types of things you might usually want to happen. At least report, okay, we've got an anomaly here. And basically, what the tool does is look for three types of anomalies. The first two really more serious types of things. One is, are you transiting routes between two peers? The second is, settlement-free peering usually has, or sometimes at least has, this clause that says, I have to advertise equally good routes to my peer on all my peering points, otherwise I could force it to do cold potato routing. Right? So are my export policies inconsistent such that I'm unintentionally or maybe intentionally forcing a peer to do cold potato routing? And then something, imagine you want to check that case from your own AS. Is one of my other peers trying to screw me? Well, the first thing I want to figure out is, am I screwing myself? That is, are my import policies consistent? Am I doing cold potato routing on my own network? So, if I see cold potato routing, I can at least figure out whether or not I should be blaming my peer. So I've had some good cooperation from some helpful souls who I'll thank in a minute, who've allowed me to run very beta versions of this tool on their configurations and help me iron out a lot of the bugs. And thankfully also their configurations had errors, so this part of the talk is a little more interesting than it would have been otherwise. But I've basically divided these errors into sort of three classes based on how serious I think they are. Maybe you've got other opinions, in which case I'm open to suggestion. But the point is basically that lots of the things that I've described to you actually turn up. So I think that a tool like RCC is actually something that people should be using, and I'd like you to use it. Again, it wasn't just that one of these one of these ASes that was so cooperative happened to give us really bad configurations. I mean, it seems to be a fairly chronic problem that these errors turn up, and this probably is not surprising to you at all. Again, one of the things that we see a lot is problems with filtering, and that's not surprising given the graph that I showed you at the beginning of the talk. So what's going on? Like, why are these problems happening, and what can we do about it? So besides the obvious thing that we can do about it, which is you all should download RCC and run it, we can sort of look. Be a little more forward-thinking and sort of figure out, what's actually causing these problems to happen in the first place. First observation is that, there are a lot of filtering problems. I've got a more detailed analysis of this, by the way, if you want me to send you a little 6-page paper about it. But what can we do about this? Well, one thing I noticed, of course, is that, of this graph I showed you at the beginning, like almost two-thirds of these announcements are from like private address space. So the first thing we should do is just do the easy thing and install filters that never have to change, right? And maybe, from a vendor perspective, maybe it would be a good thing to filter private address space by default, and then if someone wants to allow these routes, they can turn it on rather than having the default be the other way. But looking further forward, then the problem is really that the routing protocol has these intrinsic vulnerabilities. There's no notion of authentication built in, and I'm not saying that SBGP is the right thing, but the idea that authentication of routes should be built into the protocol so that it's intrinsically robust to mistakes by operators, that's generally a good idea, I think. And the second reason I think these types of things are happening is there's a lot of obscurity going on. I hope that you understood the example I presented, but there are many places I go to where you have to spend 15 minutes describing how IBGP and route reflection works before you can even get to the interesting example, and that's indicative of some pretty obscure mechanisms, and I think that people sometimes get these types of things wrong, or maybe don't even know whether or not to look for them because the mechanisms maybe aren't the right things that we should be using. And I've got a proposal that you're also welcome to see, where I've proposed essentially an alternative to how to redistribute routes inside an AS without using IBGP route reflection. Finally, something that I haven't really tackled yet, but it's pretty indicative of why a lot of these errors happen, is that people want to implement some high-level policy like don't transit between these two ASs, but the mechanisms that actually people have to use to do that are extremely indirect, right? First you have to, define your route map, and then you need to define community lists, and then you better make sure that your import and export policies are talking correctly so that I'm matching the right community regular expression on the community that I set. It's a lot of words, and it's a lot more configuration, and maybe we should think about better ways to do that. So finally, I just want to briefly summarize what I've told you. You talked a little bit about correctness definition. I gave you a demo of the tool. I hope you find it useful. And if you don't, you should tell me what the tool should have so that it's more useful. We've given you a little quick highlight of what's going on in the ASes that we've had a chance to look at. And I gave you a little rant about why I think these things are happening. I urge you to follow this link for a longer description of the tool and the study. It's available. Please, again, here's the URL. I owe a lot of thanks to many people who've helped me. In particular, Randy's given me a lot of helpful suggestions and opened quite a few doors. Many people have contributed bug fixes as far as the Cisco and Juniper parsers, and requested features, etc. And you should do the same. So, thank you very much.
We are running about 10 minutes late, but I'm sure Nick will take questions, encourage, give you places to pull down his code, but we will take questions for about 2 or 3 minutes. If someone wants to leap up instead of have lunch, have a question, we'll hold it here. Subtle. Oh, that's subtle. Okay. Please come up and ask Nick questions. I've asked him some. There's some really good work in here. And Susan has one more announcement on an operational moment.
So in particular, if I've left out, if I failed to mention any checks that, you constantly, things that you seem to get wrong that you'd like to have an automatic check for, or, other sort of properties that I've missed, I'd be very interested in hearing about that.
Thanks, Nick.
Yeah.